Hey guys, welcome back. So we finished carbohydrates. We're off to lipids, right? They're also known as fats. And so lipids again is going to be the scientific name. Common name is going to be fats. We already talked about the interactions between hydrophobic and hydrophilic. But today we're going to get a better understanding more and more about this portion here, and particularly why does fat serve this for our bodies? Okay, so for example, earlier we said, when we talked about glucose, I said, here's the molecule here, blah, 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 blah. And I said, this is the monomer, and we showed you that. This is not really a monomer, but it's not exactly a polymer. They're just, like it says, it's made out of smaller pieces. For the sake of our class, we don't really need to know the glycerol and the fatty acid. That's more of an AP biology, chemistry kind of topic. So I'm just going to skip that, but just to let you know those are there. But let's take a look at this. Now, this here is a fatty acid chain, okay? Now, if you take a look, it's a carbon, a carbon, a carbon, a carbon, a carbon, all right? This carbon is the whole way around. Now, the shorthand of this is really simple. It's just, right? Every time I bend, this bend is a carbon coming down, it's a carbon coming up, it's a carbon coming down, it's a carbon, just like in the picture. However, it is faster and easier just to draw the bend, okay? So a lot of times you could see, remember when I drew the picture of glucose like this, right? This is just a shorthand because I could do it nice and fast. Or I can do the carbon, 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 oxygen, and you can see what I mean. It takes a little time. So just a real quick refresher, a lot of times, anytime you see a bend in a object, even if it's something like this, right? Each bend that there is on the molecule, that is a carbon. Okay, so you can see that these guys are going to be full of carbons down the line. All right, so let's talk about fats, and then let's talk about its properties. Fats, lipids, we need them to live. They're very, very important. The first one is going to be here. Is we know that lipids are a form of energy storage, right? You have too much energy, you had a little abundance of food, you got to store the energy somewhere, and we store them as fat. This is not new knowledge. We knew this from elementary school or something, right? We know fats are for waterproofing. This is what we talked about earlier with hydrophobic and hydrophilic interactions, right? Now, what's interesting about waterproofing is that this helps a lot. During the week, we're going to be doing this experiment with an egg. We're going to be able to move water freely between the egg and out. So we're going to make it so big that your egg is going to look like a water balloon. And then we're going to deflate it where you can just flap it around and it just looks like really weird. And we're going to do that because there's no fat barrier separating water molecules moving through it. So we're going to look at pretty much diffusion of it. So this waterproofing is very important to us, right? Because your skin has a large layer of fat, and that layer of fat is going to keep water from out, so it kind of beads off of you. And then the last time you probably witnessed this is if you took a long bath, shower in fresh water, or you went swimming. Now, not swimming in the ocean because that's salt water, it's a little different, but if you had fresh water. So this is a picture of sitting in a bath. Your fingertips and your feet get all pruny, don't they? And the reason why is because you have a lot less fat on your hands than you do on the outer portions of your body. So the water is able to enter into here. However, underneath your layer of skin over here, there is connective tissue and some other ligaments on the inside where you just can't get past that fat layer. So it gets trapped in between your fingers. So what happens? You get out and you feel like, my fingers are squishy, and you do this. But eventually they go away. It's not like it absorbs into your body. It's just evaporating and it's just moving out into the outer area, right? So your body gets rid of it, but it's waterproofs the rest of your body, right? Now, I purposely did not, I went too far back, did not write number 3 here. And the reason why I did not write number 3 here, because this is only for animals, okay? The layer of fats are function of insulation, okay? So what happens is animals are able to store the fat as insulation to keep them warm, right? You don't go to the North Pole and say, "Oh, look at the fat plant. It has all that fat on it." It doesn't, you don't say those kind of things, right? You say it about a polar bear or a walrus or a whale, right? All the blubber and stuff like that. But we don't say that about plants as much, and so that's why this number doesn't have it. Now, plants use the first two a lot, right? But insulation is more of an animal thing for warmth. Okay, so whenever you talk about fats, fats can have a misconception of a good name or a bad name. So, for example, the saturated fat, right? Saturated fat, this is the bad one, right? And why is it considered the bad one with my beautiful drawings here, all right? Well, first reason is that it is solid at room temperature, okay? Now, this is important because I'll explain our wonderful cooking skills here. And the second thing is this is, of course, usually animal fat or lard, etc., etc. So I'm going to use my favorite. Now, if you know anything about a good steak, meat, if you've been to Gen or any of those kind of like buffet restaurants where you can buy quality of cuts, right? Let's just say you go to one of them, I think it's like $35 for like a plate of the regular beef, and it's $45 for the medium and $55 for the premium. So what's the difference? Well, for those meaties out there, we know there's a term called marbling, right? So what I'm drawing here is just speckles of fat throughout the meat, because the meat itself doesn't really hold much flavor. It's the fat when cooked, right? We know a solid turns to liquid when added to heat, right? So these solid chunks of fat will melt and the oils will spread out to the area provided to it, and then that distribution of oils is the flavor we like, savory, right? And we enjoy that flavor, okay? Also, if you think about it, we have this giant bacon, right? You get those long strips, right? The whole top, this part is all white at the top, and maybe you get these random speckles of pink here or there. But isn't it weird after you cook it? Isn't it like all shriveled and about a quarter of its size, if anything, and it looks like that, right? Well, because most of it is fat, and again, that fat is a solid, but when you add heat, it becomes a liquid, and that's why when you look at your dishes or your pan, it is full of like bacon oil. Okay, so solid liquid, we know it turns into oil, and the flavors come in from this stuff called marbling through your meat, right? This is also why when you go to like events, buffet lines, right? You got that guy sitting at the end of the buffet line with this nice, beautiful slab of prime rib, right? And what happens is this is normally a heat lamp, right? A little chef with his hat, knife sitting there. Hey, would you like a slice? You say, sure, he'll cut you off a slice. But the question is, how come the setup is always like this, no matter where you go if they're serving it? Well, remember, heat turns this solid fat on the outside and begins to increase it, raising its temperature, turning into oil, and then the oils can enter through your meat, giving it flavor. Now, when you get it on your plate, you cut that fat off. We know that. Nobody just, I'm going to suck on this fat, right? No, nobody does that. But the fat from the meat gives the flavor that you like when you eat prime rib. Okay, so now let's talk about why it's bad. So we know the solid fat, right, on the meat is bad. It has a good flavor for us, and then that flavor dissipates and spreads through the meat in the form of an oil, right? So I'm just going to put that solid, right, plus heat equals liquid oil. Okay, good. So now what? Well, you eat this oil, right? You go and eat it with the meat. You're like, tastes good. I love bacon. I had it yesterday, in fact. I cooked up a nice little meal, okay? My wife made a BLT. You eat it. What happens is that oil is all on your food, and you eat it and you swallow it and you digest it. But what happens again is the opposite. Remember, if solid plus heat equals oil, and you have that oil liquid, and you remove the heat, also, right, you remove heat, which has another word called cool, which is going to do in your body, it's going to go from liquid state back to its solid form. So what happens? That is what's flowing around your blood. And that's why we get things like arteriosclerosis, heart attacks, heart disease, etc., etc. Now, one piece of bacon ain't gonna do it. 2 pieces of bacon ain't gonna do it. We're talking years upon years of poor health and eating too much saturated fats. That will be a big deal, and that is why we're explaining it today, which you've pretty much already learned in health class or going to learn in your health class about good and bad fats. The good fat. Now I'm going to scribble out this mono because it's just talking about the double bonds in this poly here. We just care that it's unsaturated. Okay, unsaturated is the good one. Okay, now why is it good? All right, so what happens is unsaturated is in liquid form, right, at room temp. That is different than saturated, which is solid, right? So what does that mean? Okay, this is an example of for like plant, actually vegetable oil, right? Veggie oil, right? Veggie oil, fish oil, etc., etc. All the oils. Okay, so why is it good? Well, you eat the liquid. You can heat up the liquid. What does the liquid do? It's still liquid, right? So you heat up the liquid, right? And say, in fact, I'll do the same equation. Heat plus liquid is still liquid, isn't it? Then you eat liquid, right? You eat the liquid fat. And what happens? When it cools, it returns back to its original state, which is liquid. What? Is that bad? No, it can still flow through your veins and arteries pretty easily. It won't cause clogging. It doesn't stop anywhere, right? So that's why it's considered a good fat. Now, again, that's just review from what you probably learned already in health class, and if you didn't, then it's coming attractions because you're going to learn it well. But I wanted to go with something that you didn't learn in health class, but you would learn here. Why does it have the name saturated? The reason why it's named saturated because it's saturated with hydrogens. If you take a look at this picture, doesn't every single carbon, it doesn't matter where you go, isn't every one completely full with hydrogens everywhere? Right? Every one, it doesn't matter. Every one is completely saturated with hydrogen. Unsaturated is different because, let me scribble out this mono so you don't focus that. I'm going to make a big circle because I need to write in here, right? To this. There is a double bond. Let me erase that, sorry. There is a double bond here. Right? I'm going to put DB for double bond. That double bond changes the amount of valence electrons are needed. And we have this space here. This space is missing a hydrogen. Because it's missing a hydrogen, because it has a double bond, what happens? Now it is not saturated with hydrogen, thus it is called an unsaturated fat. That's how it got its name. It has to do with not what's good or bad, I mean that's coincidental, but it has to do with the bonding patterns as well as the hydrogens. Okay, now the rest of the stuff that are going to be in the that we're going to talk about in class, like trans fat and steroids, that's not necessarily part of the requirements for class. In fact, the title on it is more for your information as far as just eating right and being aware that certain things exist. So I'm not going to include it in this video, but we will talk about it in class. I hope this video was interesting to you, and I will see you soon. Have a good day.